So far in Chapter 2, we've been looking at sets. These are collections of objects. And the next important idea is the idea of a function. And what functions do is they link together elements of sets in a specific way. We'll see how they work. And there's also lots of notation and terminology that goes with them. But we can start with a simple example. Let f be the function that gives the age of any person. So, for example, if Layla is 32 years old, then the function works like this. So think of this person going in, and this function f outputs the number 32. Okay, so any person can be an input for this function, and then what comes out is their age in years. Taking a different person, so a particular Joe is 78, then f of Joe is going to equal 78. Yeah, so that's the way you'd read this. F of whatever the input is equals the output. Alright, so this simple function just gives you back the age of anybody. Example 2, this function g. Okay, so this function takes different types of input. It takes words, and what does it give you back? It just gives you back the last letter. So if you give this function this word as input, it gives you back the D. For this word, it gives you back the last letter N. Maybe those are confusing examples. G of cat. Well, for the word cat, the last letter is T, so it returns T. All right, so those are simple examples. In general, a function f, say, could be any letter to label the function. What is it? Well, it works from a set A to a set B, and it sends each element of A, the first set, to a unique element of B. All right, so for a function, we need two sets, and the function sends each or every element of the first set to a unique element of the second set. And these two sets have names, so the first set is the domain of the function. The second set is called the codomain. And this notation means, yeah, f is a function from the set A to the set B. So that's the general notation. Then specifically. So if you take an element little a in big A and little b in big B, then f sending A to B looks like this. So we say f of A equals B. So let's go back and check our examples. So yeah, so in the first example, the domain is the set of all people. And the codomain, well, you could say it's a set of integers, whole numbers. And so each person has a unique age. So we have this uniqueness. Somebody can't have two different ages. All right, so this makes sense as a function. And also this one, yes, so here the domain is the set of words. The codomain is a set of letters. And every word gets sent to a unique letter by this function. Okay, so we have the uniqueness. All right, so that's the idea of a function. And just to emphasize the notation here, so f of A equals B. Yeah, this in algebra, this looks like a product of two numbers, but in this context, this is a special function notation. So yeah, we're not multiplying two numbers here. So f is the name of the function, A is the input, so A is going in, and then f is sending A to the output, to B. All right, so these general functions, they're just linking elements of the, every element of the domain gets linked to a unique element in the codomain. All right, some more examples. Example 3. Remember our bit strings from chapter 1. So a bit is either 0 or 1, and then you can make a string of those. All right, so a bit string, it's just a binary number. And so this function f takes inputs as bit strings that are of length at least 2, so at least 2 bits. And what's the output? Well, it just sends them to their second bit. And so a bit like the word function. All right, so this, in this example, f of 0, 1, 1. So that's a bit string of length 3. And the second bit is 1, so this function returns 1. For the string of length 4, the second bit is 0. All right, so yeah, this is just an example. So yeah, there's no reason why we're picking the second bit, but just an example. So yeah, this string has length 7, so that's a good input. But this string has only length 1, so that's not a good input. So this 0 is not in the domain of the function. So yeah, like we get an error message from the function. It doesn't like that that input. so nothing comes out. Okay, so functions are only defined on their domain. You can only put in elements of the domain into the function. All right, and one more example. A new function p sends an integer to its square. So p sends 5 to 5 squared, that's 25. Negative 2 times negative 2 is 4. 30 gets sent to 30 squared, that's 900. So these are just 3 integer examples, but so the input can be any integer. Yeah, here it is in words. Of course, you could write a formula. P of x is equal to x squared, where x can be any integer. All right, so the domain of this function is the set of integers. So for this example, p of 1/2 is undefined because 1/2 is not an integer, so we'll get another error message here. All right, so this, the first 3 examples didn't have formulas, but this last example is a example of a function with a formula. We'll see more of those. And going back to the domains and codomains, so for the codomains, you have some choice. I probably should have said what the codomains were at the beginning, but so if you're looking at people, so that first example, and their ages, well, certainly ages are integers. We don't need the negative integers or very big integers, but just to give a simple codomain, we could just say the set of all integers. For that second example with the words, so the domain of G in example 2 is the set of all words. The codomain is the set of letters, so that's what's coming out. Example 3, that F, its domain is a set of bit strings of length at least 2. What was coming out was bits, so zeros or ones, so they're certainly contained in the integers. And for P, squaring, we specified the domain of P to be the integers, and certainly integers are coming back out. All right, so we're seeing here that what's coming out doesn't have to be the whole codomain. For example 3, we just have zeros and ones coming out, so certainly not every integer is coming out. So this definition the range is defined as what does come out. So the range of a function is the subset of the codomain that are outputs of the function. All right, so the range is just telling you what the outputs look like. It's going to be some subset of the codomain. Yeah, so I was looking up what the oldest age can be. Yeah, so it's maybe around 120. Okay, so for any person, if you put a person into that first function f, it gives you back a number between 0 and 120 roughly. So that's the range of that first function f. The range of g, yeah, that's easy. That's any letter. Yeah, so there is a word that ends in every letter of the alphabet. I checked. Even Q. Yeah, the range of f is just a bit, 0 or 1. And the range of that squaring function, well, it's just outputting squares. So 0, 1, 4, 9, 16. So that's the range of that function. Okay, so the first thing we can see is that each of these functions sends more than one element of the domain to the same element of the range. Okay, so each, for example, yeah, this word function going to the last letter, well, it sends each word to a unique letter, but it can send different words to the same letter. For example, box gets sent to X. Also tax, the word tax gets sent to X. All right, so any words that end in the same letter get sent to the same place. So what we're interested in is functions that never send two different elements of the domain to the same element of the range are called one-to-one functions. All right, so this word function is not one-to-one. It does send different elements of the domain to the same place. Another way to say it, a function f is one-to-one if f of a equals f of b implies that a equals b for all a and b in the domain. All right, so to be one-to-one, that's saying, well, if a and b do get sent to the same place, well, the only way that can happen is if a was equal to b. Yeah, so if you remember the contrapositive, so that the contrapositive of this is saying that if a is not equal to b, then f of a is not equal to f of b. So that's what we're saying here. Two different elements never get sent to the same element of the range. All right, so yeah, this definition is just the contrapositive, and this formulation is kind of easier to check. All right, so this is our first key property of functions. So if I give you any function, you want to know, is it one-to-one? Yeah, another name is injective, or an injection. Yeah, there's a funny mistake in the book. They call it an injunction. No, it's an injection. All right, so Yeah, we've seen the word function is not injective. What about the others? Well, yeah, lots of people can have the same age, so that age function's not injective. And yeah, the bit function's not injective. So for example, these two guys, 0000 and 101011, they get sent to the same place. So this guy's not injective. How about P? So is P injective? Does it send every different numbers? Does it always send different numbers to different places, different numbers? No. So is there another number that gets sent to 4? Sure. So -2 and 2 both get sent to the same place, so P is not injective. Yeah, so for this function, yeah, any number and its negative or its opposite gets sent to the same place, so not injective. Okay, 1-to-1, that's the first property, and then the second key property is a function onto. So a function is onto if its range is equal to its codomain. This means that every element of the codomain is an output of the function. All right, so a function that has that property is called onto or surjective. The function's a surjection. And just going back to our examples one last time, yeah, so this first one, yeah, we're not, if the codomain is a set of integers, then we're not hitting every integer, so f is not onto. For G, looking at the last letter of each word, this is onto, so every letter in the alphabet gets hit. This F with the bits is not onto, we're not hitting every integer, and P is also not onto, we're only hitting some of the integers. All right, so Q, so G at least is onto. Okay, so in this section we look at pictures to help us understand these concepts. And yeah, looking at some very simple functions. So let A be the set 0, 1, 3. Let B be 2, 8, 9. We can define a simple function f from A to B by setting, okay, so we just need to know what this, where f sends these elements in the domain. Well, we're sending 0 to 2. 1 is getting sent to 9, and 3 in the domain is getting sent to 8. All right, so we made a good function. Each element in the domain is getting sent to a unique element in the codomain. And here's the picture. So here's the domain A. Here's the codomain B with their 3 elements each. And then we can use arrows to see what gets sent where. So yeah, so 0 getting sent to 2, 1 to 9, and 3 to 8. And all right, so this is a good picture, at least for simple functions. You can draw this picture if the a and b are not too big. Okay, so is this f one-to-one or onto? Well, first, yeah, it's easy to see it's onto, so everything in the codomain is getting hit by an arrow. All right, so the range is 2, 8, 9. That's equal to the codomain. Is this f one-to-one? So do different elements of the domain get sent to different elements in the codomain? Yeah, so these 3 are all getting sent to 3 different places. So this f is one-to-one. One more definition. Yeah, a function is called a one-to-one correspondence, also bijective, if it is both one-to-one and onto. So this f here, yeah, this is a one-to-one correspondence. It's onto and one-to-one. All right, so you can see why it's called a correspondence. So for each element in A, there's a corresponding element in B. Okay, so it's the two sets are kind of linked up nicely. All right, let's look at example 6 where things don't work out as nicely. So this time the domain S is equal to these letters, X, Y, Z. The codomain is 3, 4, 5, 6. And we set up another easy function from S to T. Okay, so where does G send the elements of the domain? Well, X gets sent to 5, Y gets sent to 4, and Z gets sent to 4. Draw G and decide if it's one-to-one or onto. All right, so we have the domain here. That's G. And the codomain here, T. Okay, so just list the elements of the sets, and yeah, you can put a dot for each element. So X gets sent to 5, so there's an arrow from X to 5, Y to 4, and Z to 4. Alright, so yeah, we can see this function is not one-to-one because Y and Z get sent to the same place. Alright, so 2 arrows pointing to the same element in the codomain. That means the function is not one-to-one. And also we can see it's not onto, so not everything in the codomain gets hit by an arrow. So 3 and 6 are missing. So the range is not the full codomain T. All right, so if two or more arrows hit the same thing, then it's not one-to-one. And if no arrows hit something in the codomain, then it's not onto. Okay, you can see the difference with that first function. So this G, it's not one-to-one, it's not onto, so it's certainly not one-to-one correspondence. We're not linking up the elements of S and T. And so this is a good way to think about functions. Arrows, things in the domain getting sent to things in the codomain. So that's the main idea. Yeah, here's a good arrow picture in the book. So this function assigns grades to students in a class. All right, so each student gets a letter grade. Yeah, in this example, it's not one-to-one, so two students getting an A. And this function is not onto, so D. Nobody got a D here, so this function is not onto either. So here's the general picture. So a function f sending elements in the domain A to the codomain B. Yeah, functions, they're also called maps. So instead of saying they're sending, you can think of them, say they're mapping. So A gets mapped to B. Yeah, here's some. Yeah, here's a slightly different bit string example. So this function f sends bits. Bit strings get mapped to the last two bits. All right, so yeah, that's another variation. Yeah, we saw this one, so squaring integers. Yeah, there's so much terminology, so if the codomain of a function is a set of real numbers, then you say the function is real valued. So the values of the function, those are the outputs, what comes out. An integer valued function, that means the codomain is the set of integers. So integers coming out. Yeah, if you have two functions that are real valued, then you can, there's a way to add them together or multiply them. You just add the values. So add the outputs or multiply the outputs. All right, so yeah, so this is all covered in more detail in pre-calculus math 30. All right, so more pictures. Yeah, so this, yeah, we can see this function is one-to-one because we don't have arrows, two or more arrows pointing to the same element in the codomain. All right, so this function is one-to-one. It's not onto. 2 is missing in the range. This example, here we see the codomain is 1, 2, 3, and every element does get hit with an arrow. So this is onto. You can see it's not 1 to 1. 2 arrows hit 3. And yes, this is a good picture to see kind of all the different things that can happen. Let's take a look at it. Alright, so this picture is a function that is 1 to 1 and not onto. Yeah, so 2 is not in the range. Yeah, so it's not onto. How about this one? This is onto and not 1 to 1. Yeah, the range is equal to the codomain, and we can see, yeah, it's not 1 to 1. 2 arrows hitting 2. And this picture C, this is 1 to 1 and onto. Yeah, onto. And 1 to 1. So this is a 1 to 1 correspondence. It has both properties, and again you can see that the A, B, C, D, we can link that to the codomain 1, 2, 3, 4. So there's a correspondence between these two sets. Alright, another combination. Yeah, so this one is not 1 to 1 and it's not onto. And so that's the fourth possibility. Yep. And how about E? So this is not a function. So what's the problem? Well, we have, so every element in the domain gets sent somewhere, but the problem is here. So A is not sent to a unique place. It's sent to 2 different places. So to be a function, everything has to get sent uniquely somewhere. So it can't. So elements in the domain can't get sent to 2 different places in the range. All right. So this. Okay, so if you see 2 arrows like this, then yeah, there's a problem. That's not a function. Alright, so yeah, going back to formulas, we're using this notation R for the set of real numbers. Example 7, let Q be a function from R to R, from the real numbers to the real numbers, given by this formula. Q of x is equal to 3x minus 1. Find Q of 0 and Q of 1/3. Alright, so first, where does Q send 0? Okay, so we're just substituting, so just replace x by 0 on both sides. So 3 times x, that's 3 times 0, minus 1 is negative 1. So q sends 0 to negative 1. Okay, so if 0 goes in, then negative 1 comes out. How about if 1/3 goes in? Okay, so now we're putting in 1/3. So it's 3 times 1/3. So 3 times 1/3, that's 1. Minus 1 is 0. So when 1/3 goes in, 0 comes out. Yeah, we can't really draw a picture. We have the whole set of real numbers on the left and the right, but just examples of 2 arrows. Yeah, so 0 gets sent to negative 1, and 1/3 gets sent to 0. All right, so if you have functions given by formulas, then for any particular input, you're just substituting that number for the x. So just a substitution and evaluation. Example 8, so show that q in example 7 is 1-to-1 and onto. All right, so first to show that q is 1-to-1, so suppose we have two real numbers a and b, so that q of a is equal to q of b. Okay, so to show that q is 1-to-1, we want to prove that this implies that a has to equal b. Okay, so if q of a is equal to q of b, that means that just from the definition of q, so if you have a instead of x or b instead of x, so this is q of a, this is q of b. Okay, so we know we're assuming they're equal to begin with. What does that tell us about how a and b are related? Well, if you add 1 to both sides, that tells you that 3a is equal to 3b, and then divide both sides by 3. That tells you that a has to equal b. All right, so so if two numbers get sent to the same place, then really they had to be the same number to begin with. Remember our definition. So function f is 1-to-1 if f of a equals f of b implies that a equals b. With the contrapositive, if a is not equal to b, that implies f of a is not equal to f of b. All right, so this type of argument shows that q is 1-to-1. Okay, so if I give you 2 different numbers, they always get sent to different places. To show that q is onto, so the last part, well, take any real number y in the codomain, so yeah, real number. Can we find a real x so that x gets sent to y by q? So can we find an x so that 3x minus 1 is equal to y? So what x makes this true? Yes, add 1 to both sides, divide by 3. Alright, so we're just starting with this equation, which comes from this. And solving for x. Alright, so can we find an x so that q of x is equal to y for any, so starting with any y? The answer is yes. So this is the x we need. So for example, yeah, if you're checking, pick a random number, 63.41. So is this in the range? Yes, because if you take this number, Q sends this number to 63.41. Just by our argument here. Alright, so any y, any real number y gets hit by something. So that tells us that Q is onto. Alright, so this function Q, it's onto and 1-to-1, so it's setting up a 1-to-1 correspondence from the real number line to itself. Okay, we'll see next time that special functions like this, we can reverse all the arrows and get a new function called the inverse. Okay, yeah, so that's the first part. We'll continue with functions in the next part.